So if I have this block that is held motionless, motionless means that all of the forces are in equilibrium with one another. Then on a frictionless plane by means of a light rope, which is parallel with the plane. The plane is inclined at 35 degrees to the horizontal. So there's my 35 degrees. Draw the force diagram for the block showing all the forces acting on it and name the object which exerts each force. So the first force is weight or gravitational force, and it is exerted by the earth on the block. The next force that we are interested in is tension, and it is exerted by the rope. And finally, there is going to be a normal force, which is exerted by the plane. And the plane, it's always at 90 degrees to the plane. Draw a diagram to show how the gravitational force acting on the block can be resolved into its components, parallel and perpendicular to the plane. So I'm going to draw a diagram separately here. That's my weight. And then parallel to the plane, this can be resolved into a force acting down like that, which is going to be equal to the tension, because this is all stationary, and perpendicular to the plane, there is going to be a force over here, which is going to be equivalent to the normal. There is 90 degrees between the tension and the normal, and there's 90 degrees between the tension equivalent and the normal equivalent in the resolving of this into components. Remember, I could also just bring that down there and create a parallelogram around that weight force. I do know an angle. I have been given 35 degrees over there, so when I bring that force down there, it's going to be 35 degrees. So this is going to turn out to be 35 degrees between the normal and the normal equivalent force and the weight. Now we need to resolve it. If the force in the rope is 5 newtons, calculate the weight of the block. So I have been given that the force in the rope, which is the tension, is equal to 5 newtons. So that's 5 newtons over here. And that is opposite to my 35 degrees. And in doing that, opposite means I'm going to use sine, and I'm going to say sine of 35 degrees is equal to the opposite, which is 5, over the weight, which is W, and what happens is the weight turns out then to be 8,72 newtons. A crate of luggage, which is being loaded into an aircraft, weighs 2 tons. So the weight is 2,000 kilograms, and when I multiply 2,000 kilograms by 9,8, I land up with 19,600. Newtons. So that's my actual weight. The driver of a loading lift accidentally presses the wrong control button. Back leg of the lift folds in, with the result that the platform forms an angle of 30 degrees with the horizontal. Will the crate slide down the inclined plane if the maximum frictional force between the crate and the plane is 12,000 newtons? Prove your answer with the necessary calculations. So I know that I could have a maximum frictional force of 12,000 newtons. That's a max though. That's not the actual frictional force. So what I'm going to do is I am going to work out the component of weight down the slope, and that will have the component of weight acting down or parallel to the plane. So if I am going to work out the component of weight that is there, I land up with 30 degrees in that angle over between the normal equivalent or the component of weight that is perpendicular to the plane, and I've got 19,600 there. So if I bring this down over here, I land up with the opposite side. So I'm going to work with sine, and I land up with sine of 30 degrees is equal to the opposite side, which I do not know, over the 19,600. So we land up then with this force being equivalent to 9,800 newtons. So the down the slope force is 9,800. The maximum frictional is 12. 12,000 is greater than 9,800, so it won't slide down the slope. An object with a weight of 100 newtons is at rest on a slope. If the friction parallel to that slope prevents the object from sliding is 64,28, then what is the value of the angle? So I'm going to bring down my force over there. I'm interested in that angle, and I know that across here I've got 64,28. That's my opposite side. I know my weight, which is my hypotenuse, because remember my 90 degree is in over there, so my weight is going to be 100. So I know my opposite and I know my hypotenuse, so I'm going to say sine of the angle I do not know is my opposite over the hypotenuse, and I land up with my angle being equal to 40 degrees, which is answer C. We've got a 4,5 kilogram object, and this time it is actually moving down the plane. So let's try and, so everything's not balanced. I'm going to put my 4,5 kilogram object over there, and I'm obviously then going to have a weight, and the weight is going to be 4,5 times 9,8, and it turns out to be 44,1 newtons acting down. I then have to, I've got 36 degrees over here, so when I bring my perpendicular over there, which will be balanced with the normal, by the way, so that's going to be fine. And I'm going to get 36 degrees inside over there as well. And then I have got the coefficient of friction. They tell me something about the coefficient of friction. And the frictional force, remember, is equal to mu, the normal force. So the coefficient of friction I've got is 0,548. But I don't know the frictional force and I don't know the normal force. What is the net force on this object? I can work out this force over here, which is the component parallel. So first, if I'm going to calculate the component that is adjacent over here, so I'm looking at this force normal over here, which is equivalent to the perpendicular component of weight, and I land up with cos of 36 degrees is equal to my adjacent side, which I don't know, we'll just call it adjacent, over my weight, which is 44,1, and my adjacent side, which I don't know, which is going to be equal to the force normal, turns out to be 35,68. I can now substitute in 35,68 over here, and I find my frictional force is going to be 19,55. So that's the frictional force. The next thing I can work out is the opposite side, which means I go sine of 36 degrees is equal to the opposite that I don't know over 44,1, and my opposite side then turns out to be 25,92 newtons. So down this hill is 25,92 newtons. Now I need to get the net force, and I need to look at what's happening parallel to the slope, and I'm going to say 25,92 down the slope minus 19,55 up the slope is equal to 6,37 newtons down the slope. There are also here are some extra resources that you can take a look at. Remember, Khan Academy also has a video on inclined planes, and here are some extra examples that you can look through.